How's it going, everyone? Today we're going to cover one of Python's most misunderstood concepts in classes, which involves the use of underscores. In a lot of programming languages, we have the concept of private and protected. When learning Python, you might come across some articles online that tell you that this is how you create private and protected attributes in Python. Here we use one underscore for protected attributes and two underscores for private attributes. This is a common misconception, but before I explain why, I'd like to thank Zed for sponsoring today's video. It's the code editor that I'm currently using. If you feel like trying out Zed, I've left a link in the description box down below where you can download it for free. So, as I was saying, it's a common misconception that using a single leading underscore creates a protected attribute, and using a double leading underscore creates a private attribute. The first rule of Python is that we do not speak of Python. The second rule of Python is that nothing you create is ever truly private or protected. No matter how hard we try to make something private or protected, there will always be a way to access it. If we print the object, you'll notice that the two attributes we created are still very visible and can be accessed. Although one has been mangled, making it slightly harder to use, and the other one is over here. And we can refer to these attributes without an issue. Python will not stop us from trying to access them. So, what's up with that? Why do codebases still use this in their classes? Well, for the single underscore, it's merely a convention used to tell devs to treat an attribute as protected. For example, imagine you have a user class that contains a name, an age, and a user ID, which will look like this. Both name and age is public information, but the user ID isn't something we want the developer using this class to touch. So here we can use the single leading underscore as a message to the developer telling them that this attribute is protected. You shouldn't touch it and that it's for internal use only. We can also mark methods as protected. It delivers the same message, that this should not be used outside of this class or its subclasses. It is used internally to ensure other functionality works as intended. If a developer was to use this method directly, it would feel very random, because what the method does might not really seem like it concerns the current user. Then you can define functionality that calls the methods that are to only be used with the class. This gives the user of the class a meaningful entry point to using the class. Now, when we create our instance of the class, we will know exactly which methods and attributes were meant for us and which ones were not. Using dot notation, we can try to get some info, then we can try to reset the ID and get some more info. And if we run this, we will get the info back before the reset and after the reset. But as I mentioned before, we can still access all of the functionality we marked as protected. It's just a bit random. I mean, here we generated a random ID, but it did not affect the instance of the class. So we'd have to use this method at our own risk. We don't know what it can affect. The only thing we know is that it's protected, which means we shouldn't be using it out in the open. Great, so we now know that using a leading underscore is merely a convention and nothing else. But what about the double leading underscore? Why can't we access the private attribute the same way we access any other attributes? First of all, it's not a private attribute. The reason we can't access it the same way is because the double underscore triggers special behavior in Python called name mangling. Name mangling is intended to help us avoid name collisions when subclassing. It practically just renames the attribute to include the class's name. As you can see here, this private attribute becomes this. Or to be more specific, it becomes this part over here. It includes the class's name followed by the attribute. And since it's difficult or inconvenient to access the attribute this way, it's understandable that devs might consider it to be private by this point. But as you can see, we can still run this code and access that attribute. But now let's look at an example where name mangling saves the day. Imagine you have a parent class, and that parent class has an attribute called name, which is set to parent. And this parent class will also have a method that prints the current name. Next, imagine you have a child class that inherits from the parent class. Inside the init block, we use super to initialize the parent class. Then, once again, we create an attribute called name. And finally, we create a method that prints the current name of the child. With these two classes, I can finally show you the importance of name mangling. So let's create an instance of the child class. Then let's call the method that gets the current name from both classes. So here we will get the child name, and here we will get the parent name. And when we run this, you'll see that we will get the child and the parent. Theoretically, the name attribute inside the child class should have caused a name collision, since it has the same name as the name in the parent class. But since we told Python to mangle the names, Python was able to create two different versions of the same name attribute before we used our class. And you can see both of the mangled names when you print the object's dictionary. As you can see here, the name that refers to parent is actually called parent name, and the one that refers to the child is called child name. So Python created unique attribute names for both of them to avoid that name collision. Now watch what happens when you remove the leading underscores. So here we'll just remove that, remove that, remove that, and remove that. And the next time we run this, we're going to end up with a silly bug. As you can see, you end up with a child class that completely replaced the parent's name, which is something you probably didn't want to happen. Ideally, you'd want the method from the parent's class to return the correct value. Unfortunately, we overwrote the original value here. So now both the parent and the child class use this name, which again is very silly. So to summarize everything, use a single leading underscore when you want to inform other devs that an attribute is protected or to be used internally. Use a double leading underscore when you want to use name mangling to avoid name collisions through inheritance. You can also use name mangling on its own inside a parent class, but that will require you to invent and share your own conventions with your team. Anyway, I'd love to hear your thoughts on the leading and double leading underscores from this video. Do you use name mangling? Do you use this syntax for other things? Do let me know in the comment section down below. But otherwise, with all that being said, thanks for watching and I'll see you in the next video.